The following video is on areas for trapezoids and circles. So here's kind of a summary of all the things that we've learned so far. Area of a triangle is 1/2 base times height, or 1/2 AB times the sine of C, and the pictures are on the side. Parallelograms area is base times height. Squares area is side squared, and rectangles area is base times height or length times width. Notice that a square and a rectangle are actually both parallelograms, so you could use the parallelogram formula for a square or a rectangle. Now, these new formulas we're going to learn about. The B's represent bases, and the H represents a height in the trapezoid formula. And then the circle formula has a radius for R. So let's talk a little bit about this. So if I'm looking at the area of a trapezoid, I have everything labeled. Base 1 is up on the top. Base 2 is on the bottom. And for the purposes of showing you why it works, I broke base 2 up into 3 parts. One of them I'm calling X, the other one I'm calling Y, and then this one is exactly the same length as B1 because I've broken it up into a rectangle. And then H represents the height. So what I did was I kind of just took this exact thing and I broke it into 3 parts. So I have a triangle. The area of a triangle is 1/2 base times height, and this X represents the base. Then I have a rectangle, so base 1, B1, times the height. And then I have another triangle over here, and this triangle over here is represented by 1/2 times Y times H. So that is kind of the breakdown of what all of these things are. Now, I noticed that there was an H in all 3 of them. So with algebra, I can factor out an H. But this is still not really that helpful. I mean, that doesn't get me to the formula that we had on the previous page. So um, what I notice is I can actually take this rectangle and cut that into 2 triangles also. So what I'm going to do is I'm going to take that rectangle and cut it into 2 triangles. And so if I do that, I'll just going to break the triangles apart. So oh, I didn't want to move all the H's. Um, so we have an H now still here, and we have an H over here. And then now what I have when I look at this problem is I have 4 triangles. So I have the triangle that was originally in red, 1/2 XH. I have the triangle that was originally in green, 1/2 XY. And now I have this rectangle is now broken into 2 triangles that have 1/2 times B1 times H, 1/2 base times height. And so that's what this represents. So now what I can do is I notice that there's a 1/2 H in all of the terms. So there's a 1/2 and an H in all of the terms. So I can factor out a 1/2 H. And then I'm left with X plus B1 plus B1 plus Y on the inside. Now, if I regroup these, notice that X plus B1 plus Y, if I added all 3 of these things together, that was B2 in my original thing. So I'm going to rewrite this as B2. And so now notice I have 1/2 times H times B1 plus B2. If I slightly rearrange that, that's exactly the formula that we had. 1/2 B1 plus B2 times the height. So now let's do a couple practice problems in order to make sure that we know what we're doing when we actually see a problem. So it's one thing to know why it works. It's another thing to be able to do it. So we have a height of 12. We have one base is 38. The other base is 44. I know the area formula is 1/2 B1 plus B2 times the height. So 1/2 times 38 plus 44 times 12. So I just type that in the calculator and I get the answer. What I end up with is 492 inches squared. Notice that everything's in terms of inches. So that means when I take the area, I have inches squared. A couple more problems where we may have to work backwards. Like what happens if I have to find the height? So the area equals 1/2 b1 plus b2 times the height. I know the area, the problem gives it to me. That's 935 square centimeters. So I have 1/2, b1 is 30, b2 is 55. Those are just in the problem. And then I have h. So now I multiply both sides by 2, and I get 1,870 equals 85 times h. So I just did two things there. I got rid of the 1/2 by multiplying both sides by 2. So then that gets rid of the 1/2 and then makes this 1870. And then I added 30 and 55 together. Now I divide both sides by 85. So 1870 divided by 85 gives me 22. And that's the answer, 22 centimeters. Notice that all of these units are in centimeters. This problem, the area is still equal to 1/2 b1 plus b2. Notice that's in parentheses, times the height. So I'm just going to start replacing things. One of my bases is 5. It doesn't matter whether I choose that to be b1 or b2. I'll choose it to be b2 just because. And then my height is 2. And then it tells me my area is 7.5 inches squared. So now I can multiply both sides by 2 to get rid of the 1/2. And I could distribute everything, but it's easier to actually not distribute everything. So I'm going to divide both sides by 2, and that gets rid of the 2. So now I'm left with 7.5 again equals b1 plus 5. Subtract 5 from both sides, and that base is 2.5, 2.5 square, not inches squared. My fault. That's kind of an important thing. It's not inches squared because it's not finding an area, it's just finding that length. So it's just 2.5 inches. Area of a circle. If that's the radius, the area of a circle is pi r squared. In terms of why it works, that's a little bit beyond the scope of our course, but it's pretty simple. I mean, if I have this problem, the radius is 7, area equals pi times 7 squared. One thing that kids make mistakes on calculator parts of problems is they will type in something like this, where they type in the pi to be squared. This is not good. We cannot square the pi. It's not telling us to square the pi. It's telling us to square the radius. So I want to make sure I square the 7. So the area here is 49 pi. That's an exact answer, and that's inches squared. If we wanted a rounded answer, 49 pi is equal to 153.938, and then that's inches squared. This problem up here, the radius is given, so all we have to do is plug it in. Area equals pi times 4 squared. So the area is 16 pi millimeters squared. And I can continue, just type that in the calculator, and I get 50.265 millimeters squared. One other thing to keep in mind is sometimes they'll give you the diameter. So in this problem, they gave us a diameter of 14. I have to understand that that means the radius is 7. And then I would basically do the exact same thing I did for this problem because they have the same numbers. The only thing that's different is in this problem, I would write 153.938 centimeters squared because the units changed.